Yeah, welcome. Late in the afternoon, welcome to those who survived in this good mood to attend this very, very interesting conference that I did the day. I have with me today, and I want to start with a part of the panel, two distinguished panelists here in the room and three panelists virtually connected. Let me start with the colleagues sitting here in the meeting room. It is first Ragnar Rattas, if I may ask you also to join us from CybExer Technologies, and Mr. Stefano Serva from the European Space Agency. So we are already complete here on stage, and with us we have Mathieu Bailly, a well-known face to this conference because he was already in the panel earlier this morning. And with Mathieu, we are connected also to Pawel Fleischer and Łukasz from Transition Technologies Managed Services. Welcome also to both of you. So this panel is about cyber ranges. In the afternoon, we went, I would say brutally, to space, talked about warfare. And then we went into the bits and bytes when we heard about a lot of space technologies, new ideas. But in particular, thinking back to this panel on space warfare, that was for me an eye-opener, and it was a kind of a brainstorming exercise. And I think the guys agreed even to that, and even the moderator engaged in this brainstorming. And the bottom line was, well, there are many risks that are not yet understood. And also there is a lot work in front of us because cyber there's a high human dimension in this cyber. And you know, a human being is actually unpredictable. And this we need to manage in a way, or at least to simulate. We heard about the evil experimentator. We heard about hacker. We heard about, how was it called, irrational attackers. So we probably won't cover this area, but all this makes it necessary to prepare as good as we can to these potential risks and to be in a position to mitigate them. And as Annette already introduced and made a reference to the Cyber Ranges projects that we have been running in the EDA. I think that is a good example, to bring together different platforms and to create a wider simulation environment. And that is the topic of our panel today. We now go from space back to the ground again, to the cyber ranges, and I want to start with a short round of introduction of all the panelists, where I will ask them to present where are you from, what is the key business you are doing in your company, and maybe, if time allows, the three most important keywords that you attach to cyber ranges, to explain me, because I'm a space guy in EDA, not necessarily a cyber guy, to explain me and also the audience what a cyber range is. Ragnar, would you like to start?
Yeah, I can go first.
Please, go ahead.
So, good afternoon. My name is Ragnar Rattas. I'm from an Estonian company called CybExer Technologies, and we do provide cyber range as a product and also as a service. I'm there working as a cyber range team leader, so me and my team, we are the technical architects behind designing and implementing cyber ranges and exercises and training events on top of there. Over the years, I must say that space wasn't the first place where we looked. So we started from, let's say, civil sector, military, critical infrastructure. But over the years, we also have included various space technologies onto our cyber range. And this is where my experience is with the cyber range and space. Regarding the, let's say, things to point out regarding the space cyber ranges, then one of the feeling what I've kind of developed in my experience when working with different space technologies is that the industry itself, it's very conservative. And sometimes, yes, it's a good. I understand also the backgrounds. It was discussed earlier that the mistakes that you make are tremendously expensive. But also this attitude of being very conservative and let's say saying no to many new things also creates a situation where you're missing new things, like the use and benefits of cyber ranges, the trainings, etc. And in the same time, in the earlier panels, we saw that the modern technology is sneaking in there. You have your software-defined satellites, IP connectivity, Linux servers running on space. And if your mindset does not change together with the technology, then you will be in a pretty bad situation in upcoming years. And perhaps with that, I will give word to others.
Thank you. Maybe we first pass the floor to one of the virtually connected panelists, Mathieu. May I ask to introduce yourself again and that what you are doing in relation to cyber ranges?
Thank you, Holger. It's a pleasure to be here remotely. My name is Mathieu Bailly. I'm heading the space activities at CYSECi. CYSECi is a company headquartered in Switzerland. And we actually just announced today that we raised money in France. So we are expanding also in France. Our value proposition on the market is to offer end-to-end security products for new space missions, small sats in particular. And cyber range is a very exciting topic for us as a supplier of security product. So as we've discussed today, as we heard it during the conference, cybersecurity is a fairly new topic to the space industry, especially to the commercial missions. And we do need a platform, a place to try out these products, to test the different threats, to test the level of robustness of security products. This is really a need from the market, from the operators. So there is an absolute place for cyber ranges on the market. And also then it triggers a lot of questions about where, who, how much, who pays for it. We need it for MOD, DOD. We need it at the European level. We need it also for commercial operators. We need a ground cyber range. We also need an onboard cyber range, which is a little bit complicated to make. We discussed this morning with Dave Evans, the manager of the OPSAT mission, the possibility to use OPSAT as a test bed also for security experiments. We tried to do that this year. It didn't go well because of the war in Ukraine. But I think this is a way to go as the European ecosystem to have these capabilities end-to-end, as the title of the panel is, on ground and on board, to better build the security environment for the data and for all the services that can be provided via space missions.
Thank you very much. You raised the keyword, or one of the keywords, end-to-end. I think that is the decisive part, to have it really from the ground to space. Stefano, what are your activities from the European Space Agency? And we heard this morning a lot of very, very, very ambitious activities ongoing with a lot of money. Many billions have been seen on the screens of your colleagues on the slide. And what are you doing in this regard?
So, good afternoon, everybody. So, I'm Stefano Serva from the ESA Security Office that acts as the security authority for ESA. So we are inside the agency taking into account the security of our space program and of our infrastructure. And in particular, myself, I'm responsible for the security of the space program, so to check that proper security has been implemented. And in this regard, when it comes to the topic of this panel, that is the development and the operation of cyber range, we in ESA, we are developing our Security Cyber Center of Excellence that will be in Redu and will also be operated from all our center. And this infrastructure will be crucial because it will allow the European Space Agency to support the development of the program, so support security testing, qualification, verification of the security functionality, then the validation of the operation of the system, and then exercise and training for the operator, and finally also the sharing of the threat intelligence that we will collect also through our operational system in support on this testing. So you understand it's quite a comprehensive package that we want to tailor specifically for the space environment. And if I have to say which are three main features that we believe are essential for such a system, I would say, first of all, it should be able to support the overall development life cycle. So we want, as I have already said, to really support the system during the design, but then during the security testing, the qualification, and then up to the operational validation. We want the system to be able to provide a threat engine, I would say, a capability to emulate the threat landscape in which our system, and in particular our space system, will operate. And finally, for me, I would say it's essential also that this system support gathering of assurance. How much is the security that has been implemented in the system? So to allow an evaluation of this level of security.
Thank you very much. Last not least, the two colleagues from TTMS. I don't know who will speak first.
Perhaps Pawel.
Okay, Pawel, please go ahead.
Sorry, I hope that you hear me very good. I'm sorry that I'm not with you on site, but I'm attending NATO Edge conference in Mons in Belgium, where we're also discussing many issues related to the cybersecurity and protecting the satellites and the whole infrastructure. So TTMS is a IT company from Poland where we hiring more than 750 people, and we would like, together with Łukasz, share our thoughts about our work which we have done for ESOC when it comes to our project related to SecLab, when we cooperate with, for example, with Daniel Fischer on that. But I would like to also say something different, because everybody is concerned on typical technical solutions. But we are forgetting that without ensuring the physical security, like zoning, securing data centers, without the personal security when it comes to the security clearances, security checks, and without ensuring information protection when it comes to the classified or unclassified data or parameters used in the space systems, we cannot talk about the comprehensive link security when it comes to space systems. And so at the end, of course, there is the final product, which is our cyber range, but we, or our colleagues' technical solutions. But we have to not forget about those critical steps which are before that, and have to be made by every organization. Thank you.
Thank you very much. So you say security can only be as strong as the weakest link, as the weakest part in the security chain, of course. Okay. Thank you very much for this first introduction. If we continue a bit, so I try to summarize the cyber range's main purpose, in my understanding, is test own security features, support research, build competence, raise awareness, but of course also prepare for the future, develop further capabilities. And if I may start again with you, Ragnar, your company is specialized in cyber ranges, from the creation, from the development to the maintenance to operation. What are the key challenges in really designing and building a cyber range?
So maybe I will, let's say, focus on the space component on the cyber range, and I would say that for us the biggest challenge is that we don't have the know-how of the space industry, and it's not something that you can learn from the internet. And the way how we have approached this is to find a good partner who kind of has the space knowledge and know-how, and then we bring on the table the cyber ranges design, the exercises, the trainings, and all that. And so far it has worked. But on the other side, what I also have seen is that, let's say that the market on the space cyber ranges, what I've seen so far, it's very tiny, and it's been driven by, let's say, not enthusiasts, but let's say the leading powers like European Defence Agency, European Space Agency, and so on. And then the cyber ranges projects, what I've seen, they tend to be very, very big and huge and complex and kind of do everything. And while it's nice to implement also those, but I foresee that in near future, we should also start to, I don't know, not to create like one size fits all cyber ranges, but to have something that you use for training workforce and then let's say raising cyber skills, and perhaps there would be dedicated ones which you use for testing your actual missions, having to replica, hardware sets and so on. Because in my perspective, like from cyber range perspective and cyber attacks and defense side, the hardware and then that is important, but from attacker perspective, if you have IP connectivity to the system and you see some Linux running there, some vulnerabilities, this is what you're looking for. It's not necessarily like hardware faults or so on. And also, in many cases, what I see in the real world is that the cyber attacks, they are not so glamorous and advanced as you might think. They are not attacking the bare underlying hardware. Instead, they search for the weakest link, and for example, it might be the satellite operator's workstation, which gives direct access to mission control system, and you can just send in commands. So, in my experience, I would say that the current space cyber range projects, they tend to be very huge, consume a lot of resources, and then they want to kind of to create many things, not to say all of the things that you can do with cyber range.
Okay, so there seems to be no gold-plated and one-size-fits-all solution.
At least to me, currently it seems so, that you cannot have a perfect cyber range that does everything.
Okay. Stefano, let's go from the design and building to the operation of a cyber range, where your experience clearly lies. You have Redu in Belgium. You have mentioned your security operation center. What can you say as regards the needs and capabilities such a cyber range should support from your experience in operation, and what is the role in ESA of such a cyber range for space security testing? We heard validation, all of these necessary steps that need to take part until you can bring a product on the market.
Okay, thank you for this question. So as I said, in terms of needs that are behind the ESA Security Cyber Center of Excellence, we already told that there are these different steps. So I start with security testing, verification and qualification of the functionality, then the need to validate the operation and therefore the way the system has been put together with the way it is operated, and then to train the operator properly on the system. So all these elements I understand that are challenging to put together, but it's also true that when you are being capable to build a coherent and a representative model of the threat environment, and then you couple this with a coherent and representative threat model of the system, and you put this thing together, is really an added value that you can use this coupling, this synthetic environment that you have created, not only to support the development, but also to support the validation of the operation and the training of the personnel. Because you can reuse basically the two main functionality that are, on one side, the capability to model the system, on the other side, the capability to model the threats environment that is at the end what is interesting to understand and how the system reacts to this. So I would say, in terms of capability that are needed, first of all, the capability to create this synthetic environment where you model the system, and the system could be complex because there could be elements of the system that we have to model, elements of the system that we bring inside the cyber range, like hardware in the loop, other things that we interconnect from the external world. So this is a very complex setup, and we should have a system that is customizable to cope with this challenge. Then I would say it's important that we are able to create an engine that is able to model the threat. And this engine should have its own, I would say, intelligence. So by using the cyber range itself, we build the knowledge of the cyber range. And the added value is the fact that reusing the cyber range, we have more and more understanding how to model the threats and how to apply these threats to different kind of system. So I would say these are essential capabilities that we need. In terms of role that the SCOE could have inside the agency in support of the European Space Agency program, I would say, first of all, as I mentioned, to be able to support the development of the space program. So when you have to perform security testing, you will have a reference system that you can plug your system on, obviously with the proper interface. So it's a support to the supplier, it's a support to the development challenge. Then we have the role to support also the understanding of the security risk, because usually we spend a lot of effort in performing a top-down security risk assessment. In this regard, it's important to match this top-down analysis with a bottom-up feedback coming from the application of the real threats to the system. And so we can match the model that we are creating of the risk assessment with the actual findings that we are having on the system. And then another important element, role, is that this system could support the evaluators, so who is going at the end to assess the level of security of the system, so the level of assurance that the system could provide in giving a rate, in evaluating the quality of the implementation of the security. And so in this regard, the cyber range could become a cooperative environment in which both the supplier and also the evaluator could work together to understand if the system is working and what is the level of security that is achieved. And finally, I would say that is also during the maintenance and the operation of the system, the cyber range could become that support for continuous penetration testing on the system to understand that there is no regression in terms of the quality of the security that it provides when you make any patch on the system.
Thank you very much. Very impressive what's going on in the day-to-day operation of a cyber range. Let's go back to the virtual colleagues again. Mathieu, please. Your company is kind of specialized in data security. And what challenges do you see to protect the data of a space mission? And then an add-on question, do you think that cloud approaches or cloud solutions, we heard this word during the day already, that such an approach could help to contribute, to enhance, to ensure this protection?
Mm-hmm. Thank you, Holger. Maybe just before answering your question, if I may follow up after what Stefano just mentioned and also Ragnar, we are more concerned about the commercial space missions, as I mentioned at the beginning. I was, let's say, very supportive of the comments of Ragnar from CybExer to say that they were experts in cyber ranges and they were lacking the expertise of space. And I think that's very representative of what we have today on the market, is that we have cybersecurity companies that are really specialized and good at what they do in security. We have space companies that have been building satellites, that are building satellites constellations. But what we need to do is to make these two worlds talk together. So I think the partnership that CybExer has with this space company is extremely interesting. And this is what we need to encourage. I'm very happy to hear Stefano's describing the Center of Excellence at REDU, really taking care of the security topic for institutional missions. But we must not forget that a lot of sensitive data, a lot of assets, typically satellites, are in terms of number, in terms of value, are from new space commercial players. When we're talking about the number of satellites being launched, only a very small part is institutional missions. So we need to be able also to address that segment of the market that also does need the the state-of-the-art security products and practices. So we need to make sure that operators have off-the-shelf or accessible, technically and financially, not only security products, this is what we do at CYSEC, but also all the other tools that are used by security companies out there and on other more mature markets, verticals like finances, for example. So including cyber ranges. So we need to be able to build that, to address that commercial ecosystem, to gain maturity all together. Now to answer your question, the typical challenges and threats, I could talk about that for hours, but to make it simple, there are two challenges. The one is really about the operations of the satellite, and so typically on ground, the mission control software responsible to send the telecommand to the satellite, and on board the onboard computer that responsible to receive the telecommand and to send the telemetry. So obviously securing this link is very important to keep the control of your satellite, to make sure that nobody is hacking and taking control of your satellite. And also on the side about the payload data, which is usually a different link, securing the data link, the data themselves, but also the software. We see more and more, we talked about it this morning, that the trend is to be able to push software packaged in containers, if we're using DevSecOps, Docker, Kubernetes, and to send that to a satellite in orbit, on a shared infrastructure in orbit. And this creates a massive amount of security challenges that have been solved in cloud computing on Earth. So we need to be able to duplicate the solutions, the tools that have been developed in cloud computing on Earth, and to apply that in space. So that's what we're trying to solve.
Okay, thank you very much. And you paved the way in a perfect manner to another question I have, because for me this telecommand link is key. When you lose the satellite, any security feature that you may have implemented as regards the payload is in vain, and all the effort is gone. So the question to the TTMS colleagues: what challenges do you see in particular protecting this link? And do you have already solutions, or do you see new solutions coming up?
Yeah, sure. We can assure that the outcomes which came out from our SecLab project, and I think that the first and foremost is the preservation of the secret communication. One of the elements that makes this possible, for example, is to ensure security on the communication by introducing the encryption keys, security association data log that are entered into SDLS. We have to also take into consideration that the situation is even easier when we are dealing with the encrypted satellite broadband signals that are that can be intercepted across vast of distance. And in that case, is that where we can implement the network security, which can help and enhance the situation. We can use delay-tolerant networking or physical layer encryption. From our project, also, it came out that the challenge for preserving the communication safe is that the messages comes from a trusted source. Everyone is familiar with the term of spoofing, which refers to discussing a communication from unknown sources as being from unknown. So one of the solutions to that is transmit the signal on the right frequencies and provide onboard verification of incoming signals. But today, when we have several satellite systems, transmit either unauthenticated messages or authenticated at the application layer, or via either symmetrically implicting authentication or by public key solutions, is still a challenge. Yeah, we can do that, and it works. Third, we have to underline that there is also a problem with protection against the falsification of the messages which we are sending to the satellite. That these false messages can be injected into legitimate transmission relays. Due to the fact that satellites are resource limited and sometimes their lack of capability and or it's very cheaply to verify incoming transmissions for reply. So the answer for that challenge is it's perhaps quite easy or not, depending on approach coming from the service provider or solution provider, is to generate a private key that is assigned to the message and delivered to the satellite. But I think so. Also, what is arising, and it's very known in the ground networks, is the protection of the onboard systems against the DDoS attacks. In spite of the fact that even when we have a strong, secure communication solution is deployed, it doesn't guarantee avoiding of mission loss due to the other attack techniques like DDoS or DOS. So we have to somehow in future figure out how to fight that kind of attacks.
Thank you very much.
Thank you.
And I heard that you also have some slides for us at the end of the panel. So we started the day with some slides, and we will close the day with some slides. But I ask you for a little bit of patience, and let's first go through the questions maybe also the audience may have, and after that you will have then some minutes for presenting your slides on your ideas and products. Final round of questions, if I may, though the end of the day is coming. Please, a short reply. So we have described a bit where all these activities come from, where they originate. We have seen what is ongoing, and now we should also take an outlook into the future. So what will the future bring? Where do we need to act to become better? We heard already this morning other sectors should be approached, other sectors that we can help off. So the terrestrial world was meant where many solutions are already in place, meaning security, cybersecurity solutions, and that may just be transferred. So what will the future bring, and where should we take a look, liaise, partner with to become better? Ragnar, if you want again.
Okay, I can go first. So after this conference and hearing what has been said, I'm more than convinced that, let's say, traditional IT, modern IT technologies will find their way to satellites and space technologies because it is commercially feasible. And this all creates and increases the surface for cyber attacks and cyber domain in general. Now the question is that will the cybersecurity solutions, including cyber ranges, go on organically as the space industry kind of changes? Is one thing, it can happen, or alternatively we need one very good crisis, for example, like it was the Stuxnet and industrial control systems, which kind of is so groundbreaking that it creates a big tension, and then the cybersecurity starts to go into operational technologies. Because nowadays it's not very weird that your railroad company kind of addresses themselves as being more IT company than a railroad company, and it's also perfectly okay that your power companies and power distribution grid operators have cybersecurity engineers, and then they're very common. So I think that all in all, the cybersecurity definitely will come. Question is only either it will come like from the start organically, or it will come with big bang after a big crisis.
Thank you. Stefan, your views.
So my view is that obviously security is at the center of the attention in our agency, because we are more and more aware of the threats that surround the interest that the attacker have, since space infrastructure are becoming more and more essential for the lives of the citizen. So there is also an interest in this case to attack this infrastructure. So I believe that the awareness is there, and the cyber range should be an instrument to help to understand if we are applying security properly in the system, where we have to apply more, where we have to apply less, in order to be very focused, because we don't have to over-engineer the security there. In terms of plan for the evolution of this capability, for sure, at the moment we are addressing all our unclassified system. That is a large part of our activity, but for the future we also plan to address classified system. So we have the ambition to have a fully suitable and developed tools to address the full spectrum of the activity that we are doing. And finally, also considering that there is an evolution in the quantum technology, we want to be sure that our cyber range is also addressing and suitable to model and to support the quantum initiative that are taken care by the agency.
Whenever it will come, that we heard in the previous panel. Okay, thank you for that. Mathieu, your vision on the future.
Yeah, to me, there are three main points I'll try to describe shortly. First one, on ground, as we discussed, we need to have cyber range solutions that are technically and financially accessible for commercial operators. So it could be cyber range as a service in the cloud, for example, just an idea I just got, or something that people can use easily on the ground. We need to have also something representative of the flight of the space segment. I mentioned before, UpSat is an option. We need to duplicate that and to make it accessible. We see the US Air Force doing hackers competition on their satellites next year. So far, they've done ACASAT only on the ground, and next year they'll do it on a constellation called the Moonlighter project. We need that also from a European perspective. This is, in my opinion, a must-have. And also, last but not least, the threats that are serving as inputs to these ranges, they need to be as realistic as possible. In the US, again, I'm sorry to bring this up, but it's always a pity that we look up to what the US are doing. They have the Space ISAC Information and Sharing Analysis Center, which works quite well. So as Europeans, we need to think whether or not we want to have a similar setup to be able to share the threats that are posed on space systems. And these threats can then be used as inputs to the cyber ranges solutions.
Thank you. I think that what the US is doing is certainly of a great value, and it makes sense, even working for a European agency, of course, to take a look and also to talk to them, absolutely. But at the end of the day, as my opinion, we should also then go ahead and strive for own solutions, of course, and look that we are, in a way, autonomous and self-sustaining in also in this area. Last vision from Pawel, please.
I will have a very small cherry to put on the cake. I think so. I agree with my predecessors, but I would like to only say that I think so. The biggest thing is to be in line with the standards, which are coming from the US, the NIST standards when it comes to the ground swim protection, and when to do the CCSDS standard, which are also crucial. That we are lack of I think so in the European Union, and ESA, of course, we have the CCSDS standards, but when we go to the nations, it doesn't work like that, because the different nations are implementing different standards, cybersecurity standards, mostly coming from the IT security. If it's well, let's say enough, I'm not sure. I think so that we're supposed to start to have a real discussion in the European space cyber community, how we would like to implement the new standards and what are the upcoming challenges. And we're supposed to have an additional, body that will start to put the pressure on the producers, but also operators to implement those standards in their products and services.
Thank you very much. With that, I would like to pass the floor to the audience and ask for questions and look for hands raised. In case you have questions, please. Yeah, there's one just next to you.
Hello, this is Priit Anton from Guardtime. I have a question about the mindset change related to space cyber ranges. I mean, the war in Ukraine and the robustness of like the attacks in our critical infrastructure and systems, this has kind of proven that you don't have to like go a very fancy attack in one way. You can do in very kind of throw a Molotov cocktail in a generator and then when the system is down, attack something in a totally different manner. So have you seen this kind of a mindset change also in your work and how we assess the risk and attack scenarios that can be implemented? Thank you.
Thank you. Well, I would rephrase it also in a different manner. Was there a mindset change visible? Was it even necessary, or was this what happened and what was addressed in the question? Was it just boosted or underlined the importance of your work actually that you are doing? Who wants to start with that? Or to reply, and it's not needed that all of you reply.
I can give a quick answer and perhaps let others also. My feedback on the mindset change comes via, let's say, our partners who are space industry companies. And at least the impression what I've got is that no, there hasn't been significant mindset change and awareness but it can be biased, meaning that I'm working with more like startup companies, universities, and so on. I'm very certain that the perspective is different.
Yeah. Was it also due to money?
It can be a little bit, yeah.
Okay.
I would say that for sure the work together with the project stakeholder to understand their needs in terms of security was already there, and awareness is a key, no? Because if the stakeholder are not really aware what could happen to their system in case a threat materialize, obviously it's difficult then to really have them investing the money and resources in security. But I would say that this is, first of all, something that should be taken through governance, should be taken through the policies, and this the agency was already fully suited. It's true that what happened has given a boost to the awareness, because for sure has put a spotlight in terms of the needs in cybersecurity, and so people are even started to investigate and to acquire more information on this autonomously.
Thank you. Further questions? I don't know whether we have questions online. No. Okay. Further questions here? If not, I would now hand quickly over to your colleague, Pawel, namely to Łukasz, for a presentation that he prepared on something I'm not aware. So please, Łukasz, go ahead.
Okay. Good afternoon. My name is Łukasz Pieczonka, and I am a software architect in TTMS, and I'm responsible for space sector. Today, I will tell you about long-term mission maintenance, especially about threats and what to do not to lose the mission. So plenty of issues have been raised today, so I think my presentation will be some kind of summary of today's day. So as you can see, there are plenty of threats, mainly caused by hardware failures, software failures, and communication. I will focus on communication threats. It can be traffic analysis, link jamming, packet replay on unauthorized access. The last one is highly dangerous because it may cause spacecraft interception and a mission loss. Denial of service or distributed denial of service attacks can also be highly dangerous for a mission. We cannot forget about cybersecurity at ground control. Leakage of encryption keys, passwords, or other crucial settings due to software threats or social engineering can cause unauthorized access to a spacecraft and consequently a mission loss. But why the cybersecurity in space is so important nowadays, much more than 40 years ago? The answer lies in technology development. When a mission is planned, future technology is not known, but a spacecraft will be flying also in the future. Here you can see two examples. The first is Voyager 1 mission being prepared during 1970s, launched in 1977, and is still flying. Yes, 45 years later, the mission is still operational. The second example is the Rosetta mission, approved in 1993, launched in 2004, and ended in 2016, 23 years later. At the right side of the screen, you can see the engineering model of the Rosetta spacecraft. I took this photo 1.5 months after the mission was ended. I saw that time computer equipment, which was very popular in mid-90s, and completely outdated and no longer available in 2016. At the bottom of the slide, I would like to remind you development of data processing and communication devices during last 50 years. This is the way from costly, simple devices to cheap, complex ones, which are highly functional and accessible for everyone, ubiquitous. Let me show you a few examples. First is radio modem, very flexible in use with high capabilities. The second one is also the radio modem, but this is dedicated for LoRa modulation, extremely simple in use. The last one is being sold as DVB-T tuner, but in fact it is software-defined radio with very high range of frequency. Simply, it was cheaper to build DVB-T tuner on such kind of device. Look at the costs, like a dinner in a restaurant, not expensive one. Everyone can buy and everyone can build a communication solution on it, including for unauthorized communication. How to protect a spacecraft against cyber attacks? The first solution is obvious, to secure the space link. It is all the parties shall be authenticated and confidential data shall be encrypted. It's obvious. The remote onboard security management shall be deployed. In long-term mission encryption, keys may be unveiled and compromised. In such cases, it may be necessary to periodically to change keys and to upload a new ones if necessary. All secure communication and management shall be compliant with SDSC standards. Why? Simply because to not forget about some important aspects during the mission software implementation. Remote update is also important. For example, after a dozen of years of mission, some encryption algorithm may appear too weak because of better breaking encryption algorithm techniques available now. Me and Pawel, we took part in the 3 projects of cybersecurity for European Space Agency. During these projects, we tested cybersecurity techniques in space-to-ground communication. Under the scope of these projects, we implemented and tested possibility of using onboard Ethernet network and IP-based communication between ground and onboard computers. Our team developed also secure communication model directly from ground to onboard computers using software-defined network techniques. Then we developed and tested space-to-ground communication using SDLS protocol. It is an encrypted version of SDLP. We tested also possibility of using lightweight encryption algorithm and assessed their demanding for CPU power. We tested resistance of SDLS, IPsec, and DTLS protocols for various signal disruption levels. Finally, we implemented and tested SDLS extended procedures standard, tested and validated it, and gave our recommendation for changes. The standard was still under the development during the time of the project. All three projects form the CCLab research laboratory. All the laboratory was built on 100% virtualized environment. It consists also from ESA software, including mission control system SCOS 2000. All developed communication elements are compliant with CCSDS standards. Unfortunately, today we have not enough time to go deeper in details. However, fortunately, everything was described in the book Space Operations, published this year, so everyone can see the details of the CCLab. So that's all from my side. Thank you for your attention.
Thank you very much, Łukasz, for being so concise in this promotion video. It was not a video, it was a slideshow. Thank you very much, and maybe you triggered interest for some to take a deeper look into this book. With that, from my side, thank you to the audience, thank you to the people virtually collected, but mainly a big thanks to the two colleagues sitting here in the panel and to the three colleagues virtually connected for sharing their really, really huge competence with this panel and with the audience. And with that, I have only to say again, thank you very much. Ask the audience for a big round of applause.